Okay, so first part of this chapter is about matter, and you should be able to understand what is matter and how do you identify the matter. So let me give you the definition of matter and why it is important because we are going to study matter or different types of substances in this class. That's why it's important. And matter is anything that has mass and also a volume, which means it's take up space. So as an example, this pen. So this pen has a certain mass and also it has a certain volume. So this object or this uh, satisfied the condition of both of these mass and volume. So it's a mass. And mass is not always visible. It can be invisible, like air. So if you have a gas tank, empty versus filled gas tank has two different masses. Okay, so gas has a or air has a mass, and also it fills up this cylinder. So it's going to take a space or volume. So there are different types of matter. Okay, so the tiniest particle of this matter is going to be the atom or molecule. So every matter is made of tiny particles, and those are called atoms or molecules. So there are different types of matter based on the composition, and we are going to talk about that later. So mainly we can classify matter into two different classifications. So first one is based on the state of matter, and the next one is based on the composition of matter. So I don't have much slide related to the state of matter because I'm sure you may have learned it from another class, but I will give you the basic properties of each state of this matter. Okay, so first we are going to talk about the classification of matter based on the state. And there are three states of a matter, and those are solid, liquid, and gas. So we are going to start from the solid state. Okay. So if it is a solid material, when we analyze a solid substance in the particle level, so this has tiny particles. These can be atoms or molecules, and these particles are closely packed like this. Okay, so that's the particle arrangement of a solid matter. Closely packed particles. Okay. So these particles has very strong interactions between each other. That's why it's going to stay close to each other. So interactions between particles are very strong. Solid matter. Also, these particles are in constant motion and a fixed position. So these particles vibrate all the time. We don't see those vibrations, but there are some vibrations. So even the atoms in this pen is constantly vibrate. So we don't feel it, we don't see it because it's in the particle level and it's a very small particle which we cannot see from the naked eye. So particles vibrate. At a fixed location, fixed position, which means this particle does not pass or go in between other particles. So it's going to stay at a certain location and vibrates. Also, if it is a solid substance, it has a definite shape and a volume. So volume and shape is definite. So there's a definite shape and a volume for a solid object. Any question? Okay, so those are basic properties of any solid matter. Okay, so normally solids are going to be at the lower temperature side. So this is going to be the low temperature. Solids exhibits at low temperature. That's an example. Ice. Ice is a solid and it's going to stay in solid state below 0 degrees Celsius. That's below 0 degrees Celsius or 32 degree Fahrenheit. So did everyone note down those points because those doesn't in the slides? Let's move on to the next state. So next state is a liquid state. So if it is a liquid, an example, let's say water. The water is a molecule which has two different types of elements, hydrogen and oxygen. So water molecule is going to be in this shape. So there's one oxygen and this bonded to two hydrogens like this. So there's an angle between these two bonds and it's around 105 degrees between the, that's the bond in water molecule. Okay, so there are water molecules in a sample of water. So there are water molecules like this. Okay, again, you can see these molecules, those are the particles, so it's close to each other. So therefore, there are some strong interactions between particles. It is not strong as solid, but it's strong. The strong interactions between particles. And one of the major differences between solid and liquid state is particle mobility. So these particles can go in between other particles like this. So these particles are free to move between other particles. Are free to move. Okay. So liquid doesn't have a particular shape. So if we fill a liquid into a glass, it takes the shape of the glass. So if we fill it into a beaker, it takes the shape of the beaker. So volume is not definite, but I mean, shape is not definite, volume is definite. So we can say 1 gallon of water, 2 liters of gasoline, something like that. The volume is definite. Not definite shape. And it takes the shape of the container. Right. So example, water. So these are some of the key properties of any liquid. Strong interactions, particles are mobile, volume is definite and no definite shape, and it takes the shape of the container. So let's move on to the third state, which is the gaseous state. So there will be a few questions from these properties in the exam. So the third one is the gas state. So if it is a gas, so we can fill the gas into a container. Yes, gas particles are going to be like this container. So example, hydrogen gas, the oxygen gas. So these are the key properties. There's a larger gap. Particles in a gas. So, The distance between two particles is relatively large compared to the other two states. Okay, so there's a large gap between particles. And because of the larger gap, interactions between particles is less. So weak or no interactions. Weak or no interaction between particles. So that's why these particles are stay far apart. And also these gas particles move on straight lines and these motions are rapid. So these the gas particles move rapidly on straight lines. So anything that is in fast motion, it has more energy. So more energy means it's going to be in the high temperature side. So gases are going to be in the high temperature side. When we consider the same substance like water, low temperature side is the solid ice, medium temperature is the liquid water, and high temperature side is the steam. So increasing temperature can change the states between these three. Okay, any question? Okay, so that's the first classification based on the state of matter. So I think most of you know the properties of the those states. So that's why I did not include slides into my lecture note. So now we are going to classify matter based on the composition. So it's based on the type of the substances in a matter. So that's the second classification based on the composition. There are two different types of matter based on the composition. So some are uniform. Evenly distributed. So some materials have evenly distributed particles. So if it is no, then it is called heterogeneous. It's always going to be a mixture because if it is non-uniformly distributed means there are more than one type of substances. So it can be two different elements or two different compounds or more than two. So it's always going to be a mixture. And if it is evenly distributed, yes, then it is called homogeneous. Okay. So if it is a homogeneous substance, again, we can divide that into two different types of homogeneous substances. So one is a pure substance. The other one is going to be a mixture. So the definition of the mixture is it has more than one type of substances. So there are at least two different things mixed each other. That's the requirement to be a mixture. So we have some homogeneous mixtures, and those are called homogeneous mixtures. I will give you some examples later. And if it is a pure substance, there are two different types of pure substances. And one is element. The other one is compound. One type of element or one type of compound like water. So one type of element like carbon. So examples, anything from the periodic table, like carbon, iron, nickel, So these are elements. So if we take a sample of carbon, if it is just pure carbon sample, it has one type of carbon atom. So examples of compounds like water, sugar. Formula of sugar is C12, H22, or 11. So it's kind of a medium-sized molecule. So there are 12. And this subscript stands for the number of atoms in the molecule. So 12 carbon atoms, 22 hydrogen, and 11 oxygen atoms. Or like table salt, sodium chloride. So there are a lot of compounds. So if we take just pure water, just one type of substances, and it's evenly distributed. So it's a homogeneous pure compounds. And if it is a homogeneous mixture, it's going to be like sweet tea. So if you properly make sweet tea, you don't feel different taste for different sips. So it's going to be the same taste. So it's homogeneous mixture, like shampoo. Okay, or like household ammonium. So anything that is evenly mixed. So it has more than one type of substance. So air is also considered as a homogeneous mixture because the composition of air is relatively same throughout the world because of the wind. So air is made of 78% of nitrogen and 21% of oxygen, and remaining 1% comes from carbon dioxide, water vapor, and few other gases. That's the composition of air. So it's considered as a homogeneous mixture. So heterogeneous mixtures, examples like soil. So if we take a sample of soil, so top layer may have a grass and some dead plant materials, and there may be some sand, water, large stones. So composition is not same. So clearly homogeneous mixtures is visible. So you can see different part of the sample. So there will be a few questions from this classification in the exam. So you will be able to identify which one is the homogeneous mixture, which one is going to be the heterogeneous mixture, pure compound, and pure elements. So you can see the definition of these words in the next couple of slides. So this is the full classification based on the composition. And a substance has distinct property and composition that does not vary from sample to sample. So if it is just one type of substance like water, it doesn't matter where you're going to find water, it has the same properties. So the two types of substances are elements and compounds. An element is a substance which cannot be decomposed into substance. So if we take a sample of carbon, so we can't create anything else from carbon. It's going to be the simpler substance. So compound is a substance which can be decomposed to simpler substances because it's made up of more than one element like water. So water has two different elements, hydrogen and oxygen. Okay, so in this slide, you can see atoms and elements and compounds. So there are 7 diatomic molecules and it's made of the same element. So like hydrogen gas. So most stable form of hydrogen is hydrogen gas. So this is a diatomic molecule. So it's made from the same element. So there are 2 atoms from the same element. So there are 7 diatomic molecules like this. So hydrogen, oxygen, nitrogen, chlorine, bromine, hydrogen. So you do not need to remember this at this point. And also you have these 7 in the periodic table on your lecture notebook. So it's supposed to be on top right corner the periodic table. Okay, so all the other compounds has at least 2 different types of elements like water. So red one is the oxygen and white ones are the hydrogens. So this is another molecule, ethanol. So common alcohol mainly has ethanol. So it's made of 3 different types of elements. Those are carbon, oxygen, and hydrogen. In this molecule, there are 2 carbons. So it's going to be C2 and C2H5 and OH. So altogether there are 6 hydrogen and 1 oxygen and 2 carbon. Aspirin is the next molecule. So it's going to be C8. H9 of which there are 8 carbons, 9 hydrogens, and 4 oxygen. Okay, so why these elements are important? So some of these elements are really important because most of these elements present in Earth crust, and also a large amount of body mass comes from like few elements. So if you look at these figures, so only 5 elements make up 90% of the Earth crust by mass. So those 5 elements are silicon, oxygen, calcium, iron, and aluminum. So 90% of the Earth crust has those 5 elements. And 90% of the body mass comes from 3 different elements. Those are hydrogen, carbon, and oxygen. So now you can see oxygen plays a large role because it's highly present in Earth crust as well as human body. Okay, so each of these elements has its own symbol and a name. Okay, so next week, next Monday, you're going to get a short quiz, and it's going to be over some of these elements. So there will be 25 questions. Most of these questions are multiple choice questions. And I think I already gave you a printed copy of the elements that I'm going to test you. So if you don't have this, please get it from me. So there are roughly 50 elements in this page, and your quiz is going to be over these elements. And you do not need to memorize the spelling of these names. So I'm going to test you on identifying these elements. So most of the questions are multiple choice. That's an example. If I give you the symbol of this element, there will be several words. Nickel, neon, nitrogen. So I can let you 5 names. We start from nitrogen. So I mean, we start from N. So you're going to identify the element. So Ni stands for nickel, like that. Okay. So also, if I give you the name of the element, and you should be able to pick the right symbol. So symbol of these elements always start from an uppercase letter. So there are some elements which has only one letter for the symbol, and sometimes it can be the first letter from the name. Sometimes it might not be the first letter, but it is just a single letter. It's always uppercase. And some elements has 2 letters, and first one is always uppercase, and the second one is always lowercase. So like aluminum, so it's capital A and simple L. Okay, so with this font style, I have some issues. So this is the Arial font style. So this might read as capital I. So if you write it as AI, I stand for iodine. So there's no any element in the periodic table. It's just A. Okay. So I will avoid that confusion during the exam. So I will use Times New Roman font to type on your exam. So you can see the difference between L and I in the Times New Roman font style. So some of these symbols related to the English word, sometimes it is not related, like iron. So symbol of iron is Fe, and it is not related to the English word. I mean, a symbol is Fe, so it's not related to the English word. So it's coming from a Latin word, it's called ferrum. So Fe is the first 2 words of that word, and so that's how they get symbol. So chemistry usually represent elements as symbols. Symbols are 1 or 2 letters. The first is always capitalized. Some elements are based on Latin, Greek, or some other foreign languages. So keep that in mind when you study for the quiz, because it's not always the first letter. Okay, so now we have, so this is the definition of mixtures. The mixtures exhibit the properties of the substance that makes them. So mixtures can vary composition throughout the sample. And there are 2 different types of mixtures, heterogeneous and homogeneous. And also we consider homogeneous mixtures as solutions. Okay. The solutions are not always liquid. So like air is a solution. So this is a homogeneous mixture. And brass is solid, but it's a solution. So it's made of copper and zinc, and it's evenly distributed. So it's going to be a solid solution. And we will talk about solutions again in chapter 4. So that's a separate chapter related to solutions. Okay, let's quickly go over the answers of these questions. So there will be a couple of questions like this in the exam. So identify each of the following as a pure substance or a mixture. So first one, pasta and tomato sauce. Is it pure or mixture? It's a mixture. So next one, aluminum foil. It's a pure because it's made of aluminum. So can consider it as a pure substance. Helium, it's pure. It's the second element in the periodic table, so it's pure. And air, it's mixture. And I already gave the composition of air. Okay, so next one. Okay, so these are mixtures. So we are going to identify whether these are homogeneous or heterogeneous mixtures. So first one is fudge sundae. Is it homogeneous or heterogeneous? Heterogeneous. Good job. So next one is shampoo. Homogeneous. And sugar water. Homogeneous. So because it's going to evenly mix and form a homogeneous mixture. And peach pie. Heterogeneous. Good. So now we have identified the homogeneous and heterogeneous. So now we are going to talk about the properties of these matter. So there are two different types of properties of any matter. I mean, two different types, yes, or two different classifications. Those are physical and chemical. So we can classify some of those properties into physical properties and some are into chemical properties. So you should be able to identify the difference between the two. So physical properties are the properties that we can take without changing the identity of the substance. That's an example. So properties can divide into two different types. Those are physical and chemical. As an example, I'm going to take the mass of a substance. So let's say I have a stone. I'm going to place it on a balance and take the mass. So I can read the mass from this balance. So my property is mass because it's a physical quantity. So when we take this measurement or when we observe this property, if it does not change the identity of the substance, then it's going to be a physical property. So physical properties are produce new substances. So like color, length, volume, mass, density. So still the sample is going to be the same sample. We are not going to change the composition of the sample. So physical properties does not change the composition or produce new substances. So chemical is going to be the one change the composition. The chemical will change the composition. That's an example. I have a piece of paper. I'm going to burn this. Okay, so I'm going to use a flame. It's a flame. So once I burn this piece of paper, at the end of the burning, I make a few ash, a little bit of ash. And at the same time, this is going to produce carbon dioxide and water vapor. And maybe it produces carbon monoxide as well. So when we burn things, it always produces carbon dioxide, carbon monoxide, and water. So which means it's a new substance. So anything that produces new substances is going to be under chemical. Okay. So that's how we identify the physical and chemical properties. So I think you can see the definition in the next slide. So physical properties can be observed without changing a substance into another substance. So it does not change the identity of the substance. So if it is water, it stays as it is when we take the measurement line. volume of the water, which is the same substance. So example include color, odor, density, melting point, boiling point, and hardness. So whether it's ice, liquid water, or steam, has the same compound. Right? We do not convert water into something. Okay, so chemical properties can only be observed when a substance is changed into another substance. One common chemical property is flammability or the ability to burn in oxygen. So during the flammability, ability to burn, most of the time it produces carbon dioxide during the complete combustion and water vapor, is steam, or maybe carbon monoxide. So this is another example for chemical reaction. So hydrogen and oxygen under certain condition can produce water. So hydrogen and oxygen has two different arrangement of atoms, and water has a different arrangement of atoms. So it's changing composition. Okay. And another example for chemical change is making caramel from sugar. So caramel and sugar doesn't have the same molecule. So when you heat it, it's going to change its composition and arrange atoms differently. So then it has few properties, like it's going to be like a liquid in a liquid state, something like that. So now we talk about physical and chemical properties. So we are going to divide these physical properties into two other types of properties. And these are called intensive and extensive. Physical or physical. We're going to divide into two different types of properties, and those are intensive and extensive. I'm going to use these two words in few other places, so please understand the meaning of these two words. So if it is an extensive property, that property depends on the amount of substances we have. As an example, let's say we have two containers filled with water. So we are going to measure the mass or volume of these samples. So let's say it's mass. The mass of this water is, let's say, 25 grams. And this is not going to be 25 because this has more water. The more water means it's going to be more mass. So probably this is like 40. So mass is something that depends on the amount of material. So extensive properties depends on amount of material. So the properties that depends on the amount of material like mass, volume, and there are a few other properties like that. Those are called extensive properties. So there are some other properties which are not depends on the amount of material, and those are going to be intensive properties. So as an example, let's say we have two pieces of iron. This iron is Fe. So we can calculate the density. So we are going to talk about density later in this chapter. So density is equal to mass over volume. So now we can see both mass and volume. Both of these properties are extensive because it depends on the amount of the substance. Okay, so this one has less mass, less volume. So this has more mass, more volume. So but once we calculate the density, so we are going to end up with the same value for these. So I don't remember the density of iron, so somewhere around like 7 point something or grams per cubic centimeter. So both will have the same answer. So we can use these intensive properties to identify substances. Okay. And another example for intensive property is boiling point. So whether it's a glass of water or gallon of water, both boils at 100 degrees Celsius, or both freezes at 0 degree Celsius or 32 degree Fahrenheit. So these type of properties are called intensive properties because it does not depends on the amount of material. So you can see the two definition on this slide. The intensive properties are independent of the amount of the substances that is present. For example, include density, boiling point, melting point, color. So those does not depend on the amount of material. So these are important for identifying substances. So extensive properties depend upon the amount of substances present. So example, mass, volume, or energy. So if the samples are in different in size, so this has less energy, this has more energy because it has more material. Okay, my question is length. It is intensive or extensive physical property? Length. Length is it extensive or intensive? Extensive because let's say we have two pieces. The one with the larger length has more material. So it's something that depends on the amount of material. So it's extensive. Again, guaranteed two questions in the first exam out of these two properties. One for each, intensive and extensive. Another 5 points. Okay, any questions? So now we are going to talk about physical changes and chemical changes. So we talk about physical properties and chemical properties. So we are going to talk about physical changes and chemical changes. So how do we identify physical changes? So if it is a physical change, there are few indications that we can look to identify the physical changes. So those are change of state, change of shape, or changing temperature and volume. So I think it doesn't in this slide. So changing temperature or volume is also a physical change. Volume. That's an example. When solid ice melts into liquid water, it's just a physical change because it's under change of state. The example, ice melt. Form with water. Change of shape, like chopping a log into kindling wood. So you're changing the shape. So it's under physical change. Again, ice cream melting, change of state, water boiling in a pot. So it's just change of state. So it goes to a liquid state to gaseous state. So ice forming in a freezer. So change of state, cutting down into strips. Again, change of shape. Okay, so again, as I mentioned earlier, so it can change between the state depending on the temperature. So matter undergo change of state when it's converted from one state to another state, and there are different words for all of these changes. So I'm not going to cover that part. It is not required. So I'm sure you heard melting and freezing. So that's the solid to liquid or liquid to solid. And when it goes from liquid to gas, it's called vaporization. When it comes from gas to liquid state, it's called condensation. And also there are some substances, I don't know how many of you know this. So without showing the liquid state, it can directly go from solid state to gaseous state or come from gaseous state to solid state. Does anyone know one example for one of those substances? Dry ice, yes, good. So dry ice directly goes from solid to gas. So chemical changes, you are going to see new substances. So you have some starting materials as an example, this chemical reaction. So in the first bottle, you can see nitric acid. Nitric acid is made of hydrogen, nitrogen, and oxygen. So it's a liquid. And this is the olefin, and most of it is just copper. Okay, so solid. So when you mix these two, you're going to see the evidence of a chemical reaction. So we are going to talk about the evidence of a chemical reaction in chapter 3. Chapter 3. So you're going to see some color changes or gas formation. So in this case, you're going to see both of those. So you're going to see a new gas as a brown color, and it's NO2. It's a gas. And also you're going to see a different solution in the test tube. So that solution has copper to nitrate. So we will talk about these formulas later, so you don't need to worry about the formulas right now. So as you can see here, we started from nitric acid and copper. So this is the arrangement of our reactants. So when we mix those two, it arrange differently and produce different substances. So that's the chemical change. Always it produces new substances. In the course of a chemical reaction, the reacting substances are converted to new substances. So these new substances have new physical properties and chemical properties. So here the copper, when it reacts with nitric acid, it gives a blue solution of copper to nitrate and brown gas called nitrogen dioxide. So physical properties like color often helps us see the chemical change at effect. So there are some physical properties that we can use to identify chemical reactions. So we will talk about that in chapter 3. Okay, so there are other chemical changes. So you can see some of those examples on this slide. So iron rusting, burning, anything that involves burning is always chemical. Separation reactions are chemical reactions. Electroplating, rotting banana, vinegar and baking soda. Did anyone mix those two together? Okay, so you're going to see a gas. That gas is carbon dioxide. Okay, so cooking an egg, so it changes its action. So it's going to arrange differently. Baking cake, fireworks, chemical batteries. All those are examples of chemical changes. Okay, so let's quickly go over these questions. So classify each of the following properties as physical or chemical. So first one is ice melts in sun. Is it chemical or physical? This is physical because it's a change of state. So this is physical. Next one, copper is a shiny metal. It's a physical, it's just observation. So still it's copper, so it's physical. And paper can burn, it's a chemical. So during the burning, it's going to produce ash and carbon dioxide, so it's going to be chemical. And silver knife can tarnish, chemical. Those who have silver jewelry may have experienced this. So after certain time, it's going to have a great coating because there's a reaction between silver and oxygen from air. So it's a chemical reaction. A magnet removes iron particles from a mixture, physical or chemical. It's a physical. So, and does not change, so it's just physical. Okay, so next 5, burning a candle, chemical. And next one, ice melting on the street. It's a change of state. Yes, it is physical. And toasting a marshmallow, chemical, because it changes its texture. It's going to be chemical. And cutting a pizza, it's physical. So that's change of shape. Last one is iron rusting in an old car, chemical. Any question? Am I too fast? No, good. Okay. So we talk about mixtures, and there are 2 different types of mixtures, and those are homogeneous and heterogeneous mixtures. So we can use some physical techniques to separate component in a mixture. So you're going to try first one in the third lab. Okay, so that's going to be like 2 weeks from today. So filtration is a technique that we can use to separate substances in a mixture. So we use the filtration with a heterogeneous substance. So as an example, let's say we have a sample of muddy water. So we have some sand at the bottom, water on top of the sample. So it's not going to be a homogeneous mixture because it's going to settle down. So anything that settles down with the time is not a solution. So it's going to be a heterogeneous mixture. So if you want to separate these solid substances, so we can use a use the technique called filtration. So we have special papers that we can use to filter out the liquid from these type of sample. So the substances that cannot pass through the filter paper will be trapped on the filter paper, and we can collect the liquid under the funnel. So that's the way to separate it. So distillation is another technique, physical technique to separate a mixture of compounds based on boiling point. So this is filtration. Actually, you are going to see this precipitate in lab form. Okay, so that's a nice precipitate, yellow color one. So distillation uses differences in the boiling point of substances to separate a homogeneous mixture into its components. So the best example is the purified crude oil. The oil is a mixture of a lot of chemicals. So we can get different types of chemicals at different temperatures because the property that we are going to use in this technique is the boiling point. So one substance boil at a certain temperature. So when we heat this mixture from lower temperature to higher temperature, let's say at 65 degrees, it's going to evaporate one type of a chemical because its boiling point is 65. So then we can condense that liquid and collect it like this. So if we increase temperature by another 3 degrees, probably at 68 degrees, there's another chemical evaporate at that temperature. So we can collect that chemical and condense it. So like that, we can purify a mixture of chemicals based on its boiling point. Because when it comes to different substances, boiling point is going to be different. Sometimes there are some compounds which has the same boiling point, but most of the time it's going to be different. So third technique is called chromatography. So we don't have any lab for the distillation and chromatography, but those are nice experiments. So I just want to show you how we are going to separate chemicals based on this. So in this technique, what we are going to use is the interaction. The interaction of these chemicals between the chemical and the stationary phase. So this glass column is filled with the stationary phase. So different chemicals interact differently with that stationary phase. So if we send a mixture of chemicals from top, since those chemicals interact differently, some chemicals travel faster and some chemical travels slowly through that stationary phase. The larger the interaction, that chemical is going to retain on that stationary phase because it has more interactions. So it travels slowly. So if the interaction is weak between the stationary phase and that chemical travels fast. So after a certain time, it's going to split chemicals into different bands like this. So we can collect chemicals at different time intervals. So that's the basic idea of chromatography. So there are various developed instruments to separate chemicals like this. Okay, so let's talk about the energy. And energy is the second part of this chapter. And we are not going to spend much time on energy. So I just want to give you the definition of energy. So energy is the capacity to do work. In other words, ability to work or transfer heat. So that's the energy. So energy is the ability to do work or capacity to do work or transfer heat. So work is the energy transferred when a force exerted on an object versus a displacement of that object. That's an example. If I push this bottle from here to here, I'm doing a work. So in order to do a work, we have to have two things. First one is the force. The force is the push or pull. That's the definition of force. It is any push or pull. So next one is the displacement. So this bottle moves from here to here. So we have to have both of those to do a work. So work is equal to force times distance. So this is the force. And this is the displacement. Okay. My question is, I'm going to push this table. Am I doing any work? Am I doing any work when I'm pushing this table? No, because I do not have any displacement. So if the displacement is zero, so you are not going to do any work, but you are spending energy for that push. Okay. Any question? Okay, so we are going to talk about two forms of energy, and there will be one question from each in the first exam. Okay, so we're going to talk about two forms of energy. The first one is kinetic or kinetic energy. Abbreviate as K or G. Second one is potential. You should be able to identify which are the kinetic energy and which are the potential energies. So this is the definition of kinetic energy, energy of motion. Energy of motion is the kinetic energy. So when you run, you have a form of energy. So that's your kinetic energy. So when you drive a vehicle at a certain speed, so you have a form of energy, that's kinetic energy. So we can calculate kinetic energy according to this equation. So it's equal to 1/2 mass and square of the velocity. So we are not going to do any calculation from this equation, but just remember that. So M stands for mass and V stands for velocity. Okay, so you can think about this as the speed. So velocity and speed has the same value, but velocity has a direction and the speed doesn't have a direction. So that's the difference between the two. So you can simply assume velocity as the speed. Okay, so if the V is 0, if the speed is 0, do you have a kinetic energy? No, it is 0. So if you are not moving, you don't have kinetic energy. The vehicle is at a parked position, so it doesn't have any kinetic energy. Kinetic energy is going to be 0. And when it comes to the matter, we talk about the states of each matter, and each of these has particles. These particles has motion, whether it's a solid, liquid, or gas. There are different types of motions. So all those particles has kinetic energy, and average kinetic energy of all the particles in a matter is proportional to the temperature. The kinetic energy is proportional to the temperature or related to the temperature. So all particles have some form of a motion. So if you want to stop all those motions, that's the lowest possible temperature. Okay, so we will talk about that later and keep that in mind. So next form of energy is the potential energy. So potential energy has different forms. Or the chemical bonds is a form of potential energy. Okay, so energy due to position. Potential energy is basically energy stored in matter to be used at a later time. At later time. So there are various forms of potential energy. As an example, I have two pens. These are identicals. So when these two pens are at the same height, both of these pens has the same potential energy. So if the height is different, these two have different potential energy due to its position. Because there's a force toward the earth, that force is called gravity. So there's a form of potential energy due to gravity, and we can calculate that using this equation. So both of these pens have the same mass, same gravitational force. When the height is same, it has the same potential energy. So when the height is different, two different potential energies. Okay, so M is the mass, G is the gravity. Gravitational force. Any question? So your questions are simple. You are going to identify whether it's a potential energy or kinetic energy in the exam. So like these questions. So you can see the definition of the two energies on this slide. So kinetic energy is the energy of motion. Potential energy of an object depends on its relative position compared to the other objects or its energy stored for use at a later time. So rollerblading, so what is the form of energy? Is it kinetic or potential? Yeah. And a peanut butter and jelly sandwich as chemical, so it's going to be potential energy. Okay, so next one is moving below, kinetic energy. And gasoline in the gas tank, potential energy. So I will give you multiple choices like this, and you're going to pick the right one based on your question. It's not going to be the same choices, but you have different choices. Okay, any question? Okay, so that's the end of your lecture time, but I'm going to continue this lecture after a short break because there's a lab after this class and we have a lab today. So since I'm going to miss a couple of classes in the later in the semester, I need to catch up on your lectures. So I will continue this lecture after 10 minutes. So you can have a 10-minute break. Okay. Do you have any questions?